Hello everyone, my name is Carly Cohen and I am very excited to introduce Alie Kratzer to you, um, Executive Director of Owlfly LLC and an ESW RIT alum. I'll pass it over to you, Alie.
All right, so let me just get the screen share set up here. Okay. So hello everyone, and thank you so much for joining me today to talk about how my team and I were able to turn an ESW project into a successful business venture. Before we begin, I want to ask that you please save all questions for the end of the presentation. Thank you. So my name is Kratzer, but I like to go by Alie. I studied mechanical engineering at RIT and graduated in the spring of 2019, so about a year before the pandemic. Now, don't get me wrong, I love engineering. It is one of the most direct ways a person can affect change on the world around them, and it is a powerful tool for changing our collective futures for the better. However, an equally great passion of mine, my special interest, if you will, is insects of all things. I find them absolutely fascinating. So between engineering projects, I like to study entomology. This led me to my unusual background as both an engineer and an insect scientist, which turned out to be far more beneficial to my career than anyone could have expected. But to really understand why that is, we need to start at the beginning. This story begins at an ESW project meeting, sitting around a table in the Wallace Library at RIT. We knew we wanted to participate in the 2019 Biomimicry Challenge, but we had no idea where to start. For those of you who might not be familiar, biomimicry is the process by which engineers can use inspiration from biological systems to design better technologies. My friend Liv nudged me because she knew I was studying wasps in my free time. I thought for a moment, and my mind settled on a species called the Arctic yellowjacket. These wasps build spherical paper nests in cavities within permafrost, high above the Arctic Circle. I was suddenly struck by the absurdity of it. How was this possible? How could such a little insect survive in those conditions? Did they have some sort of antifreeze built into their bodies? Or perhaps did their nests have some sort of insulative properties that were previously unknown to science? I pitched my idea to my team, and they were immediately on board. Our biomimicry project would be about yellowjacket nests. We collected nest material from two closely related local species, the common aerial yellowjackets and the bald-faced hornet. We examined the material properties of the wasp paper and determined that paper by itself was not a very effective insulator. However, the paper structures of the nest were embedded with layers of air pockets, and the geometry of those pockets was intriguing. I measured the dimensions of each of the pockets and was surprised by their uniformity, as though there was something special about this particular geometry. We put together a crude thermal model based on our findings and a 2013 paper we found about the thermal effects of air cavities in masonry. Now, in hindsight, our thermal model was way off, and our prototype designs would not have been functional in practice. But we had no budget and very little time, so I'm still very proud of the work we managed to accomplish, even if it was purely theoretical. Our final submission did not place in the Biomimicry Design Challenge. I worked as an engineer for a large manufacturing company for about a year after college. The company laid me off shortly after the pandemic escalated in the spring of 2020. I was lucky enough to have a place to fall back to, so I moved back in with my mom and coasting on savings from my ill-fated engineering job. With few prospects and the job market in tatters, I decided it was time to try to start my own for-profit business, which became Owlfly LLC. The idea was to use what I'd learned from ESW to try and develop new sustainable tech to the point of real marketability. To that end, I enlisted the help of two fellow alumni of ESWRIT, my friends Liv Breglia and Olivier Montmayor. Our team was spread out between New Jersey, New York, and New Hampshire, so we met virtually twice a week to discuss ideas, designs, and experiments. We considered a number of potential product ideas, including a foldable wind turbine and paper made from pond algae, but ultimately we decided to continue the development of the wasp nest-inspired insulation. I set aside a budget of $1,200 of my own savings to develop the insulation. Olivier built a simple heat transfer test rig to compare and evaluate the thermal properties of our prototypes. The test chamber was built of particle board, a surface-mounted heater, and thermocouples with some fiberglass around it to act as an insulator with known properties. Then we ran a lot of experiments with prototypes of different materials, coatings, and geometries. Believe it or not, our first working insulation prototypes were cobbled together out of cereal boxes. I'm honestly still amazed that they worked at all. We iterated on our thermal models and prototype designs until we found something that both worked well and was reasonably affordable. Eventually, we settled on a design made from ducting materials that were already certified as non-combustible, which is important for something that is meant to be installed in people's walls. We named the new insulation Yellowjackets after the wasps that inspired it, and my friend Asher Cattle designed a fun logo. We contracted an engineering lab to independently verify the thermal resistance of our product and received a formal ASTM certification. It was official. Our product was already better than most insulation. Also, the reason that photo is taken outside is just because my workspace inside is a mess. But in my defense, my office is just a small corner of the living room right here. Anyway, Yellowjacket is American-made, lightweight, water-resistant, non-combustible, non-toxic, and made from sorry, I lost my place. Non-toxic, non-dusting, irritant-free, and made from recycled materials. Yellowjacket prototypes already outperform the thermal properties of most fiberglass, and our team is optimistic that improved prototypes will soon be able to surpass the thermal properties of all other commercial bat insulation on the market. So how does it work? Well, all insulation reduces the flow of thermal energy, or heat, from one surface to another. Insulation keeps the heat in during the winter and out during the summer. The same fundamental physics apply to all types of insulation, which can be loosely categorized into three main types of heat transfer. Conduction is the transfer of atomic vibrations through a material. Convection is the transfer of atomic vibrations at the surface between a solid and a fluid. And radiation is the transfer of heat through the medium of light, which is when one atom releases a photon and another atom somewhere else absorbs it. Yellowjacket insulation is made from a lattice of special air pockets, which are carefully engineered to reduce air circulation to minimize that convective heating. A low emissivity coating is applied to the internal surfaces to eliminate most radiative heating, and the walls of the pockets are thin enough to mitigate most conductive heating. Essentially, our goal is to make it as difficult as possible for energy to travel from one side of the insulation to the other. The harder it is for energy to travel, the better our insulation will be. So why is this important? Well, over 12% of the total greenhouse gas emissions from the United States can be attributed to the energy used for heating and cooling buildings. Improvements in insulation technology have the potential to drastically reduce energy use, along with all carbon emissions associated with the production and transmission of that energy. These charts show how much energy yellowjacket saves compared with the median bat of commercial fiberglass in various locations around the country. Better insulation makes a bigger impact in colder climates, but all of the locations we analyzed showed some improvement over the baseline. So the reason that yellowjacket appears to save more energy over time is because it is more efficient, but it also requires slightly more energy up front to manufacture. Though, of course, we hope to continue to improve the manufacturing process to bring those initial energy requirements down. The reason I'm so excited about this technology is because this is the level of improvement we are already seeing with our current market-ready prototypes. Some of our experimental prototypes blow these numbers out of the water. There's just so much potential here for climate change mitigation. So how is yellowjacket actually installed? Well, bats of yellowjacket can be press fit between joists, like traditional insulation. The bats can be shipped pre-assembled, or they can be shipped flat and then folded into shape on site. Alternatively, yellowjacket can be formed into large panels and installed between the exterior wall and the siding, depending on what a specific project requires. Both the bats and the panels are still in development, though we expect the bats to be commercially available within the next few months. In 2022, Son Cook of ESW HQ recommended that we should apply for funding from the National Science Foundation. The grant process itself was grueling, but in the end, we were awarded one of the most prestigious grants in the country, an NSF SBIR Phase 1 grant for $275,000. The money will be used to fund the development of better automated manufacturing equipment and scale yellowjacket production to meet market demands and lower cost to consumers. We also intend to use the funding to create even better prototypes. The thermal resistance of yellowjacket is certified at 4.1 R per inch, and the best commercial insulation is certified at 4.3 R per inch, so this should be attainable. So thank you, Son. I just so happened to be dating an amazingly talented roboticist, so I hired my girlfriend, Zoe Katz, to help build the automated manufacturing equipment. We are currently about 5 months into the project, and despite a few health-related setbacks, we are making really good progress. If we are successful and meet our goals for the NSF project as written, we will be eligible to apply for a $2 million NSF grant to build an entire factory to produce yellowjacket insulation by 2026. That is, of course, very, very far from guaranteed, but the possibility is very exciting. Either way, yellowjacket is poised to revolutionize the future of energy conservation, and we are so excited to be pushing the boundaries of sustainable technology. I hope that our story can inspire you to apply what you learn in ESW to your future careers in science and engineering. So in addition to the yellowjacket insulation, I will have a new book about cicadas out next year, which I am also very excited about. Want to know what cicadas have to do with cutting-edge solar cells? Well, that's in the book. If any of this stuff sounds interesting to you, I recommend signing up for the free Owlfly newsletter, which you can do on the homepage of our website. And remember that WASP research? Well, that became a fully illustrated award-winning field guide that established me as one of the youngest published field guide authors in history. So that's pretty neat, I think. It's a fantastic book, if I do say so myself, and you can pick up the soft cover for only $25 on the Owlfly website, plus shipping. There you can also read several other educational books about insects for free. So, all business plugs out of the way. Thank you so much for joining me today to talk about how my team and I were able to turn an ESW project into a successful business venture. I hope you enjoyed the presentation. I think we have time now for some questions, if anyone has any they would like to share.
Thank you, Alie. That was wonderful. I really, really enjoyed that. And it's so fascinating, like, to think about things like that. But I wanted to open the floor up to questions. If the participants have any questions, you can feel free to unmute if you are comfortable, or if you'd like to put your question in the chat, I can read it for you.
And if there are no questions, then oh, I think
Hi.
we have one.
Hi, I'm the most senior person here, so I was waiting for the younger ones to ask questions. It is fantastic what you did.
Thank you very
Please
much.
scale it.
We're working on it as
And
hard
it,
as we can.
yes, I'm sure you'll succeed. Um, Again, I just wanted to thank you for combining engineering with sustainability and biomimicry in the best way, meaning taking an idea to practice, and working in one of what I think is the most promising and the most necessary field, which is sustainable materials.
Absolutely.
Exactly what you are doing. um, I hope your scaling doesn't depend only on the grant, and maybe you'll be able to attract capital in other ways. I'm sure by now you are on the radar of many investors. But please keep it up. Stay with it. Um, and how do you promote your business, Chris? Is my
So
question.
I a big part of it is giving talks at conferences, if you can believe it. But yeah, going back to what you said before, yes, we do have a lot of plans to scale that do not necessarily require the grants to succeed. We are certainly eligible for a lot of different grant funding at this point, especially if we can prove that we are able to start full-scale manufacturing, which is our goal within the next few months. Once we actually do have a production line up and running, we can also fund ourselves through selling our product directly to customers. So we have a few different avenues for funding in the near future.
Are you networked in the biomimicry groups?
Not as much as I could be, to be honest. A lot of my networking is in entomology, which is not necessarily the right audience for insulation. Um, so it is something that I am actively working towards. I will be we've enrolled in a program through the National Science Foundation where we will be directly meeting with customers, like prospective customers, and gathering feedback in the first few months of 2024. So we do have plans for networking. It's incremental at this point. We're just trying to get our boots on the ground as much as we can.
So were you able to attend the Green Building trade show this year, or you're planning for next year, where a lot of building materials are being advertised like yours?
I was invited to attend, but at that point we did not have we would not have been able to sell anything to customers because we didn't have enough scale to be able to do that just yet. What we're trying to do right now is validate that because of the way our installation is, we need specialized manufacturing equipment that just doesn't exist yet to create it, which is a big part of what we're working on right now. So that's really our hurdle before we can really start attending trade shows and being able to show people, hey, here is what it is. Like we have lots of prototypes, of course, but this is the final product. You can place an order right now and we're ready. We want to get to that point before we spend a lot of money on trade shows.
Yeah. Okay, I don't want to monopolize the conversation, so I'll mute myself and allow others to ask questions.
Okay, but if nobody else does, please keep them coming.
Well, I just wanted to congratulate you for understanding what is essential in biological materials. It's not so much the chemical itself, but it's the way they're structured. And there
Absolutely.
are many natural materials that we discovered as engineers that are much stronger than anything we are able to create synthetically just by the way they are structured. Because of course, nature knows best. And most of our technology, if not all of it, it's a poor imitation of nature. So that's an exceptional insight, and it's so good that you are interested in insects, and this is how you discover this unique property of biological material, and how it proves that despite the fact that we are the brightest and the smartest, the insects have figured out better how to
well, thank you so much.
To if you allow, I didn't introduce myself. I'm also a mechanical engineer like you. I worked for a long time in manufacturing. Fortunately, I wasn't laid off immediately after I started. But I steered myself away from what I was doing in the corporate world to get deeper into sustainability, sustainable manufacturing, circular economy. So I look a lot at sustainable materials, among other things, processes, materials, design, all that. So this is an excellent success story that I'm going to promote in a few minutes on all my LinkedIn groups.
Oh, thank you very much. I really appreciate that.
Because that's what we need. Exactly. Your story, your team story. This is how it works. We can re-engineer everything. It's not that we're limited by knowledge. We're limited by inertia and fossil fuels who still want to keep us going under. And I will subscribe to your newsletter, and if you accept comments, maybe if I fall under things that might be useful to you, like companies that you might partner with or learn from.
Oh yeah, absolutely.
I will send you.
I'd really appreciate that. Thank you very much.
No, I really appreciate your work.
That's very sweet. And so wholesome. I love it.
Yeah.
We have a couple more minutes. If there are any like final closing remarks that you want to share, or maybe talk about some of like, your ESW skills that you developed through your time as a student and in HQ, and how that's helped you, get you to where you are today.
Yeah, sure. I can talk about that. So I certainly would not be in this position that I'm in today without all of the skills and resources that I was able to accumulate over time working with ESW. So I started out, RIT has a 5-year program for engineers, just standard. And I joined ESW my first year, and by 5th year I was the president of the chapter. So that's where all of my leadership skills come from. Um, so yeah, everything from engineering to manufacturing and research was a big one. I have a list somewhere, but you can imagine. But yeah, working in projects and leading projects throughout my time at ESW prepared me for this sort of potentially world-changing research, which is really exciting. And so that's why I'm also coming back here today to talk about it.